Hello, and in this video we're going to talk about something called rational exponents. And I always sort of don't like the name of this because rational exponents, rational values that are exponents could be integers. And we relatively know the properties pretty sufficiently for integers, but there's a special circumstance when you have rational exponents that are not integers. And how do we handle that? So let's go ahead, and I like to look at a basic form for this. So let's go ahead and say that I have x raised to the m over nth power. So we could look at an example like x to the 1/2, and this tends to be the most common example. This states that this will be the nth root. So also now we're getting into radicals of x to the mth power. So this will translate into a radical property. So this radical and this rational exponent will have a commonality. They will have a relationship between the two. So according to this 2 will then pop over as the index. So we're going to have the second root of x to the, and now this value here becomes my exponent. This value here becomes my exponent, and this is commonly known as the square root of x. So x to the 1/2 and the square root of x are the exact same thing. So one is written in the form of a rational exponent, the other one's written in the form of a radical. So when it comes to radicals, if they don't have the index of the radical present, then you know it to be a value of 2. So let's go ahead and try a couple of these properties out and see how we do. Let's say if we want to translate this, so we want to translate this into a radical. So we want to take x to the 3/2, not 3/3, 3/2, and translate that into a radical. So this 2 becomes the index, so it sort of goes counterclockwise to me. That's why I look at it. It goes counterclockwise. So that 2 becomes the index, and then we are left with x to the, and now this value comes and moves down, but doesn't move down as far because it's up on top, and it becomes x to the 3rd power. So the square root of x to the 3rd power, and this could also be written as the square root of x cubed. So we can also translate this back into an exponent, into a rational exponent. So let's say we have the 5th root of y to the 7th power. So we have the 5th root of y to the 7th power. So we're going to go backwards. This 5 becomes the denominator, this 5, so we're going to work backwards. This 5 would, let's go right at this y here. This 5 would then go counterclockwise and shoot up to the denominator. So I think counterclockwise. So I have 5. The 5 is below the value of 7, and this also shoots counterclockwise. It's taller, so I say it goes up higher, and this gives you y to the 7/5 y to the 7/5 power. So this is y to the 7/5 power. So often you may have to go back and forth between the two of them. If it comes to simplifying some radicals, this could be very helpful as well. So we might have to simplify some radicals. So let's say that we had the 3rd root of x to the 5th, and we multiply this by the square root of x to the 3rd power. So in this circumstance, you might say, wow, that's sort of rough. But we can convert them back to their rational exponent form. So remember, even though the index is not present, we know it to be a value of 2. So we can rewrite this as x to the 5/3, and we can multiply this by x to the 3/2. And now, since we are multiplying two similar bases, remember our exponent property of similar bases states that if we have x to the m times x to the nth power, where the same bases exist and they're positive, we can go ahead and add their exponents. So we get x to the m plus n power. So this gives us x to the 5/3 plus 3/2 power. And we don't need a calculator to do that addition. So we have 3/2, and we're adding 5/3. We know 2 times 5 gives the value of 10. 3 times 3 gives a value of 9. So I get 10 plus 9, which gives me a value of 19, all over 3 times 2, which gives me a value of 6. So this will be equal to x to the 19/6. So we can rewrite this as the 6th root of x to the 19th power. So it is very helpful to be able to convert rapidly between an exponent property that has a rational exponent and a radical property. So become very fluent with this, use it often, work back and forth, and make sure you feel comfortable in both forms.